Hello students. Today we are going to discuss about the units of work in different systems. Unit of work done. We know that work is equal to force into displacement. The unit of force is Newton. Displacement is meter. That is Newton into meter. It is also called joule. Joule is the SI unit of work done. SI unit of work done. Second unit is in CGS. In CGS system, unit of force is dyne and unit of displacement is centimeter. Dyne into centimeter is also called erg. The relation between joule and erg. We know that W is equal to F into D. In joule it is Newton into meter. In CGS system, Newton 1 Newton is 10 raised to the power 5 dyne into 10 raised to the power 2 centimeter. So 1 joule is equal to 10 raised to the power 5 plus 2. Dyne into centimeter, that is equal to 10 raised to the power 7 erg. 1 joule is equal to 10 raised to the power 7 erg. The other units of work done is the gravitational unit. First is kg watt into meter. We know that 1 kg watt is 9.8 Newton into meter. That will be equal to 9.8 Newton into meter is joule. So 1 kg watt into meter will be equal to 9.8. In CGS system, 1 gram weight is equal to 980 dyne, or 1 gram weight into centimeter is equal to 980 dyne into centimeter, and centimeter will be equal to erg, so it is equal to 980 erg. 1 gram weight into centimeter is equal to 980 or 981. One and the same thing. There is no difference between them. Now come to the conservative and non-conservative forces. There are three definitions of conservative forces. First of all, the conservative force is that force by which the work done depends on the initial position and final position, not on the length of the path. Then that force is called the conservative force. इसका हम एक एग्जांपल लेते हैं। जैसे हम बोले कि दिस इज पॉइंट ए, दिस इज अनदर पॉइंट बी, एंड वी वांट टू go from A to B with this path. This is the path number 1. Then after the second path, it will be a straight line, and the third path, if work done, W1 from first path will be equal to W2 from second path will be equal to W3 third path. So we can say the force by which this work is done is considered as conservative force. मतलब कोई भी फोर्स जिसके अंडर में ये वर्क हो रहा है जो कि केवल इनिशियल और फाइनल पोजीशन पर डिपेंड करता है, डज नॉट डिपेंड ऑन द लेंथ ऑफ द पाथ, देन दैट फोर्स इज कॉल्ड कंजर्वेटिव फोर्स. फॉर एग्जाम्पल कि हम डेफिनेशन लिख सकते हैं कि द फोर्स अंडर विच द वर्क depends on initial and final position does not depends on the length of the path, then that force is called conservative force. For example, force of gravity. This is the earth. If a body displaced from this point to h height and mass of the body is m, so the work done is force into displacement, that is equal to mgh. Either the body displaced vertically or be displaced through any other path like this or like this, the work done will be mgh only. It means work done does not depend on the length of the path, it depends on the first and last position of the body. Then the force under which the work is done is called conservative force. Here the force of gravity, or we can say the gravitational force, is a conservative force. So that gravitational force will be a conservative force. Second definition of this force, in the complete revolution, like a point A, another point is B, when we go from A and come to again point B, this will be the W1 path, it is path 1, and this is W2. And according to the second definition, the work done W1 plus W2 is equal to 0, or W1 is equal to W2 minus W2. It can say it is this path is considered as BCA and BDA. So W1 can be written as BCA and W2 written as ADB, and WBCA is equal to, if it can convert negative to positive, so it will be WBDA. It is according to the first law. When we go from B to A with the path first and with the path second, the work done are equal. It means the work done is force is conserved. So we can write in the closed path, if the total work done after complete revolution is 0, then the force under which this work is done is called conservative force.